Hi, my name is Gaurav Tripathi and welcome to this course. So in this particular course, we will talk about what is data structure and algorithm. In a short course, we are taking about the terms as a DSA. Entire course, just keep in your head that the full form of DSA is data structure and algorithms. So that what we will try to cover up in our this entire course. So basically, what we will try to do that we will try to understand first of all what is data structure. After that, we will try to understand what are the key concepts of algorithm, what is an algorithm, and how to basically we can solve any problem statement with the help of different kinds of algorithm. Now, obviously, before moving ahead towards this session, I thought that it's a quite important as an initial point to understand that after all, why this data structure algorithm is required. What's the motivation behind learning these things, right? So let me try to connect the examples, which is a real life practical scenario, so that you will try to appreciate that why you are learning these things, and then going forward you will see that that we are having a different sessions where we are talking about different kinds of data structure and different way to solve any problem using a different kinds of algorithm. Now the question is, first of all, what do you mean by data structure? I hope as the name suggests, data structure is a way to structure your data, right? Now structure meaning the organization. We want to organize the data in such a way so that it's easy to retrieve the details, easy to retrieve, store the data, right? For example, we are going to a library, and in the library the books are not organized. For example, they are not under the heading of e-commerce, computer science, and commerce. So you will get if suppose you want to search for a book, it will take a lot of time. On the other hand, if the book is organized under its main heading, which is written on the bookshelf, then it's a quite easy for us to check which book we want to get, and whether that book is available in the library or not. So basically, the important point here to understand is that what we want is we want to structure data. Okay, in order to structure data, we have different kinds of data structure. Now, here, how many different kinds of data structure we have? Here we see that we have various different kinds of data structure. One is linear based data structure and one is no linear based data structure. For example, array, for example, linked list. These are kinds of linear based data structure where, for example, stack, for example, queue. What is happening is that there is just somewhere linearity. All the elements are ordered in such a way that they are forming a linear function. Okay. Now a part of that we having something called as tree, we having something called as graph, right? So these are the different kinds of data structure we have in many more, right? So here if you will see, the question come obviously in your head that why these many data structure are required. Cannot one be enough to give the entire information or to store the entire information? The answer is no. Because why that so? Let me try to give me some simple example. I hope everyone knows that undo operation that we used to do in our system, right? What is the undo operation says? So the keyboard is Control plus Z that we use to type while doing the undo operation. Okay. So usually what happened is that suppose I delete some content, some data. Now suppose I want to get that content again. So what will happen is that I will just press Control plus Z. I will just press Control plus Z. Okay, right. Now this is something where whatever be the last information I have. that will come out. So last in, first out. This is something the application of a stake-based data structure. That's where a developer when design this keyboard, they have implement the stake-based data structure, which is basically used to store the last information that we are typing, right? Now this is something which we are saying is an example of stake-based data structure, because inside the particular operation we want to implement the LIFO kindly of terminology. Sorry, LIFO kind of terminology. Similarly, suppose you want to build some network. Suppose what I would say is that that suppose you are booking some Ola, Uber cabs. It's a booking system. Obviously, we all know. I hope everyone is aware about that. So either I suppose I using Uber or Ola. I am using Uber. So what happening is that I used to enter the destination. After entering the destination, when I click on the search button, it will try to look for the nearest cab, right? And accordingly to that, it will also give me the charges also. So here what is happening is that we are making some sort of networking on the basic of that distance. On the basic of petrol required, it is giving the charges as well. So here, if you will see, what is happening is that a graph-based data structure will walk into the picture, mainly breadth first search (BFS). So there are two type of graph travelers that we have a BFS and DFS. So here we want to find out the some sorted distance, right? So that's where the BFS come into the picture. So these things, whatever I am writing here, I am not expecting that you all know, because these things we will obviously discuss in our upcoming sessions. Okay, but here I want to just try to give you the real life application where I want to suggest you that how basically these things are useful, so that you will try to appreciate, and you will now when you will go in future anywhere, you will try to observe that. Okay, here data structure is implemented, here algorithm is going on. So what is algorithm? The logic on the top of features data structure is something which we are saying as a algorithm. Now okay, apart from that, I hope everyone is having a Spotify to listen the music, right? Now suppose in a Spotify I am moving towards next. So what is happening is that I will be able to get the next music. I will be able to get the next music, right? And when I am moving towards the previous, I am able to get the previous listened music, right? So here if you will see, in a way I am dealing with the two pointers. One is next and one is previous. And that is something which is an application of Spotify, and that is something is implemented on the top of a linked list, right? Now it can be a doubly linked list where we are having the two pointers next and previous. It can be circular linked lists where the last particular music is connected with the next first one. Okay, so so that's where that circular linked list is coming into the picture, depending upon what kinds of app you are using. These kinds of data structure are useful. Now this is where is the pointer come into the picture. Apart of that, if suppose you are going towards any e-commerce website, Flipkart, Amazon and other, okay, you are going for any e-commerce website, there you find out that there is a products. Under products, again we having any subcategory which is sub product. Okay, under that I am able to get the final product which I want to order, right? Now here if you will see, this is something which is a root node, this is something which is a leaf node, the final product which I want to get, this is something which is internal node. Now what is this all about? this is something which is application of, I hope everyone is able to understand the points as well. Trees based data structure. Trees based data structure, right? Moreover, now I hope this with the help of all these real life example, you guys will be able to get the understanding that it completely depends on the use case. It completely depends on scenario which you are trying to solve. For example, you have a record of structure. Sorry, you have a record of students, and you want to store this record. So student marks are there inside the record. So here I am having, suppose maybe 5 student, we have a 5 student, and I am storing the marks of those students. Suppose out of 100, one student got 55, one student got 75, one student got 18, one student got 85, and another got 60. Now the particular student marks, the question is, if suppose someone is saying that these student marks in this particular data may very frequent operation, if is suppose insertion and deletion, means in their record I used to insertion and deletion more frequently, very frequently. In a particular case, you will observe that the linked list is much preferred data structure, because in linked list it will be take just a constant amount of time to insert or delete any data node. Whereas the same question, if I am saying that searching is very frequent, the searching is very much frequent, so that's where you will say that that okay, if searching is frequent, array is more preferable. If searching is frequent, array is more preferable, because in the array there is a concept of random access, there is a concept of binary search, with the help of which we will be able to optimize our searching algorithm. But in linked list it's okay, it's not like that. So basically, if you will see, the same problem also can be solved using different data structure depending upon what use case we will try to solve. So with the help of all this explanation, what I want to tell you that that it simply depends on what kinds of problem you are trying to solve, and with the help of which you are should be aware about what kinds of data structure we will be using here. So that's where the different kinds of data structure play a very important role, and that's why there is need to be learn every data structure in a very much depth. A part of that, I told you, the algorithm is something, the problem logic that we are trying to solve on top of this data structure. Algorithm is something, is a sequence of steps that that to finish step, I would to say solve any particular problem. And obviously, when you are trying to solve any particular problem, will you will solve, but before that you will try to save the data in some data structure. That's where this concept is coming into the picture. So now in algorithm also we are having different kinds of algorithm. For example, divide and concatenate, greedy, and dynamic programming. All these things I will cover up in our next upcoming session, but I hope that is question which is that why this data structure is required, or why we are learn this concept of data structure and algorithm. I hope it's pretty much clear to everyone. I must say that data structure is something which you will find in every real life scenario, because it's a foundation of everything. Okay, so just try to observe now after going back to your home, that where you are observing that this kinds of data structure in your real life application is useful, apart from the example that I gave you. With this, I hope that concept is pretty much clear to everyone, and now you are all excited with me to start new course of DSA, where now I will start and I will talk about that what is the algorithm in my next upcoming session. Happy learning to all. Bye bye everyone.